Hello and welcome to the Computational Geomechanics course using CivilFEM. My name is Jalou Madiar and I am a chartered engineer having more than 30 years of international experience in civil and mining engineering, including academic, design and consulting, with strong expertise in geomechanical and geotechnical design, including numerical methods and probabilistic approaches for underground structures in various ground conditions, from jointed rock masses to frozen grounds. Currently, I am involved in one of the most significant ongoing development projects in the world and the largest binational infrastructure project between Lesotho and South Africa. It involves the construction of an intricate network of tunnels and dams to divert water from the mountains of Lesotho to South Africa. This course's main objective is to provide the students with the necessary knowledge using one of the most advanced finite element software, which is CivilFEM powered by Mark, which can be applied directly in civil engineering consulting companies, scientific research institutes, universities, and any other design and build civil engineering contractors. Typical CivilFEM applications would include linear and non-linear construction process structural analysis, seismic design, energy power plants, foundations, retaining walls, piles, hydraulic dams, structures and bridges, tunnels, rock and soil mechanics analysis, skyscrapers, and even forensic structural analysis. Also, the course provides 2D and 3D soil and rock mechanics solutions using any combination of beam, shell, and solid elements to model tunneling supports like rock bolts, trusses, anchorages, shotcrete, steel fiber reinforced shotcrete, and lining such as concrete, steel, reinforced concrete, segmental lining, and solve complex structural and soil structure interaction problems. The course layout is as follows. The first module of the course will focus on an introduction to CivilFEM and finite element analysis with CivilFEM and will describe the software capabilities and solutions. On the second module, we will learn how to create geometry and how to define materials and cross-sections, the soil and rock properties, and will discuss about material models, Moore-Coulomb, Drucker-Prager, Hook and Brown, Chem-Clay. The third module will teach us how to mesh with CivilFEM, how to define loads in CivilFEM, initial conditions and in situ stresses for soils and rock masses. Also, solution options in CivilFEM, soil structure interactions taking into account nonlinear materials, geometry and contact conditions will be covered in this module, as well as design checking of structural elements. On the fourth module, we will present the construction processes specific to tunneling, activation and deactivation of structural elements, how to access results in CivilFEM, and the students will be able to learn how to use Python with CivilFEM. The fifth module dives in a set of exercises using CivilFEM for computational geomechanics tunneling. In the final module, we will review the most important aspects of the course and prepare the students for the final evaluation. At the end of this course, called Computational Geomechanics using CivilFEM, the students will have hands-on experience in using CivilFEM powered by Mark. They will be familiar performing basic analysis using the standard graphic user interface and program approach, creating geometry, materials and sections, meshing, loads and boundary conditions, linear static analysis, and introduction to other types of analysis. I look forward to seeing you soon.